Good afternoon, everybody. My name is Charlie Nicklin. I'm the Chief Exec of IAgrE. I'd like to thank you all for joining our April lunchtime presentation. Today, I'd like to welcome Manny Vannan, who is the co-founder, managing partner and financial director of Skillicorn Technologies. Manny has over 40 years experience in banking and finance. He's a renewable energy expert, and he has also been an advisor to governments, public and private sector companies and non-profit organisations. Manny is going to introduce us to the technologies that allow Skillicorn to recover energy and nutrients from municipal and industrial waste to produce high-value organic foods and recycling of wastewater. Just before Manny starts, you're all currently muted. If you would like to ask a question, please use the chat function at the bottom of the screen, and then at the end of the presentation, we'll unmute you so you can ask in person. Okay, over to you, Manny.
Okay, thank you so much. Good afternoon once again, ladies and gentlemen. And first of all, my thanks to the Institute of Agriculture Engineers for offering me this opportunity to present a new and innovative disruptive technology for wastewater recycling. So the topic today, we are going to, discuss is nature-based solutions for wastewater recycling. Which is an evolving concept. So when you talk about wastewater recycling, I was just looking for the context, and I found this from our own Sir David, on the impact of the climate change. Now, what you see here in this picture is what we are studying, in the years, in the days, months, and years to come. So the water, the availability of water and the pollution caused by the wastewater are going to be the biggest issues that is going to, affect the sustainability of our future generations. So I cannot emphasize more than what Sir David has, made this statement. So what are we looking at? We are looking at, what are the challenges we are looking at when it comes to sourcing new water, as well as addressing the wastewater we are generating, which is increasing every day. So the sustainability, clean water sources, food security are global issues that will keep on rising because the population is growing and our needs are growing. So we are going to face this biggest challenge. Now, as you are aware, 70% of the world's available fresh water contributes to agriculture, but at the same time, the agriculture production, uses only 5% as much water as other commonly deployed agriculture systems. On the other hand, we generate, enormous wastewater, and 98% of the wastewater we are generating from our towns and cities and industries is not recycled to a drinking water quality. I mean, this is an universal phenomenon. Whether it is North America, Europe, countries in Asia, Africa, Latin America, the situation is the same. So this is the biggest threat. See, the problem with untreated wastewater is the major issue is the pollution caused by this untreated wastewater. And you look at the newspaper every day, even in the UK, you come across news of the utilities, floating the regulations and discharging untreated sewage water in our rivers, in the oceans, causing enormous pollution. So this is a major issue, and even though the governments are investing, the utilities are investing in wastewater treatment plants, the industries are investing, there is a lot of underinvestment or no investment in wastewater treatment at all. And even where wastewater treatment facilities are available, they are not treating wastewater to quaternary standards. So some are doing, secondary level treatment, or some, achieve tertiary level treatments. So this is an alarming situation which has to be, addressed immediately. And there are, of course, different options that are available for treating wastewater. And we think that, there are a lot of, challenges in adopting the existing technologies, and we need some new and innovative technology for addressing this important issue. Now, this is the scenario, the projected scenario of the water stress in 2025. So you can see what is happening in Asia, Middle East, East Africa, West Africa, and North Africa. These are all the most water stressed countries in the world, and so this is an an emerging and evolving situation, and this can also spread to other countries because one of the when the global warming goes unchecked, so there will be repercussions in terms of availability of water. Now, look at this picture. If you look at the just 10 countries in the world account for 60% of the world population, and they don't have access to clean water. And now the biggest problem is going to be for India, especially the Indian subcontinent, for India, Pakistan, and other South Asian countries. So at the same time, if you look at the cities, the global cities, which are facing this water shortage, you can see, this started, once we identified the problem with the Cape Town. So Cape Town was in the news, few years ago, and so now there are other cities in the world which are also facing a similar situation, and unless and until we take some serious steps to address this, it is going to be a difficult situation. And one of the cities identified is also London. So we need to address one of the areas where we can work on is addressing this wastewater recycling for augmenting freshwater supply. Now, when it comes to wastewater recycling, we cannot ignore the energy water nexus. Now, if you look at what is happening in the energy industry, of course, Europe, North America, we are decommissioning. We have already started the decommissioning of the coal-fired power plants, and we are switching over to renewables or gas-fired power plants. But if you look at what is happening in Africa, Asia or Latin America, still the coal-fired power stations, thermal power stations are the major generators of electricity. Now, the coal-fired power plants are the thirstiest energy source, and coal, which is also proven to be responsible for huge CO2 emissions globally, is the main fuel. Now, there is a symbiotic relationship between energy and water when it comes to these coal-fired thermal power stations, and average American home uses 23 gallons of water a month to supply the power they need. And the traditional power sources like coal or natural gas and nuclear fission, they all require this high water requirement for their operations, and it is estimated that they need 25 gallons of water on an average to produce 1 kilowatt of electricity. Now the coal plants, they top the list, and they withdraw anywhere between 20 to 60 gallons of water per kilowatt hour. And so the typical American home uses 900 kilowatts hour of electricity, which translates into nearly 23,000 gallons of water. So it is time to look at the energy water nexus as well, because what is happening is the industries, especially the heavy industries like power stations, steel industries, and other large industries, mining industries especially, are competing, for water with communities. So they are coming into conflict with the communities for accessing water. And at the same time, they are also causing heavy pollution of the wastewater they are generating, which are not treated to standards. On the other hand, even though in Europe, we have started the decommissioning of the coal-fired power plants, but still there is an issue to be addressed there. So what we are doing is we are trying to repurpose the coal-fired power plants by switching over to gas-fired power plants or renewable energy power plants. But we are not addressing the pollution already caused by these coal-fired power plants because they cause enormous damage to the environment over the time. So look at this example, of these coal-fired power plants, coal mines are causing in developing countries. So this is a picture, in one of the pictures I have selected from India. So this is, the Damodar River in the eastern state of Jharkhand in India, north, east of India. Now, this river is almost dead. It looks like a sewage, flow. I mean, so the river is completely dead. It has no life at all. So this was mainly caused by, because the state has enormous number of, coal mines, coal power stations, coal-fired power stations, as well as steel industries who are responsible for this pollution. And this is a irreparable damage the industries have caused, and this is irreversible. It is going to take hundreds of years to restore this river. So it is the same location, and you can see this SAIL is the Steel Authority of India Limited, a public sector organization in India. And so their coke oven discharges are causing this hazardous tar waste, which is also affecting, the rivers and the livelihood of the people who are living on this, river water sources. Because what is happening is this used to be the river where people used to, source their drinking water supplies, water for their agriculture, livestock, and for other uses. Now, this is the situation of the river, but people continue to and see the pollution they will be causing to the underground water. So the underground aquifers would have been completely polluted. And also, because of, drought seasons, the farmers may tend to, use this water for agriculture. Then you can imagine what happens when you use this kind of water, which contains a lot of toxic chemicals, heavy metals. So they all get into your food chain. So this is a dangerous situation. And if you look at the statistics in India, the increase in the number of, serious, health conditions like, kidney diseases, liver diseases, and cancer. One of the, major reasons is the use of this polluted water and the pollutants that are coming along with this water. So this is coming at a huge, cost to the national, health services in those countries. Now, let's come back to, the situation in the UK. Now, in the UK, I told you in the beginning itself what is happening in the wastewater recycling, industry. Even though there are regulations of what is the regulatory authority in the UK, but still, the industries, the utilities are not fulfilling the regulators, requirements. So there is an element of, cheating that is going on internationally when it comes to wastewater recycling, because wastewater recycling is not a priority for industries or for utilities, because they have been privatized. So these managements are responsible for generating profits to the investors, to the shareholders. So any investment in wastewater recycling is a sunk cost. So they don't get anything out of the wastewater recycling. And this is one of the reasons which encourages them to cut down their investment in wastewater recycling. So you will see a lot of underinvestment or no investment in wastewater recycling because of this reason, because they are not generating anything out of this wastewater treatment plants, and it is eating into their profits. Now, this has been in the media, and especially if you look at what is the situation with Southern Water, which was in the news for all the wrong reasons recently. Southern Water was fined 126 million pounds in 2019, for letting out untreated sewage water, in the ocean. Now, again, in 2021, they were fined another record, 90 million pounds, for dumping billions of liters of raw sewage to the waters of North Kent. So there has been a lot of, campaigners in Chichester Harbor, accusing the water companies dumping, wastewater, untreated wastewater, sewage water, and destroying their protected harbor environments. So this has been going on, and in fact, the investigation by the Ofwat has brought to light that the utilities not been doing this in 2019 or 2021. They have been doing this for the past 20 years. So you can imagine the amount of the pollution they have been causing all along. Now, if you look at what is the impact of this pollution, okay, this pollution is killing our rivers, it is killing our oceans, it is destroying our coastal ecosystem. Now, the amount of toxic chemicals, the heavy metals, which is all coming along with this untreated sewage water, once it is dumped in the oceans and rivers, so it is all being ingested by the fish and prawns and the lobsters we eat. So it is all coming back into our food chain. So this is what we may be eating when we eat our fish or crab or lobsters. So this is a serious issue which has to be addressed. And one of the reasons is, as I said, the main reason is there is no business case for investments in wastewater recycling. So this, unless and until we can change this, it's very difficult to encourage utilities or industries to invest in wastewater treatment. Now, this is exactly what we have been working on. So this is based on our 4 decades of R&D exercise internationally. So we thought unless and until we can develop a sustainable solution with a compelling business case, there is no way we can encourage industries and utilities to invest in wastewater recycling. So we have come out with this nature-based solution. So when I say in a nature-based solution, what do I mean? We are using, we have developed a bioreactor. Basically, the bioreactor, consists of fast-growing vascular plants like Limnaceae and a combination of microorganisms. So basically, they form the core of our wastewater recycling engine. So this is a 100% biological process. We use very minimum mechanical systems and no filters and no chemicals. So it is 100% a biological process, biological and to some extent mechanical process and hydraulic process. So this is the nature-based solution that we have developed. Now, there are some differentiators between what we have developed and what is available in the marketplace with competitors. Now, one is it's a nature-based solution, and number two, the solution can treat any wastewater, whether it is municipal wastewater, industrial wastewater, agricultural wastewater, mining wastewater. We can treat. I mean, this solution can treat any wastewater. Now, but among all the wastewater, our sweet spot is in treating municipal wastewater, because the municipal wastewater compared to the other wastewaters contains all the energy, all the nutrients, and makes it possible to recover all the water for reuse. So basically, it is lemnacid-based phytoremediation technology, wherein we recover all the nutrients and all the energy and all the water. So we can also, in addition to treating any wastewater, we can also desalinate the brackish water. And the Middle East is sitting on a huge reservoir of brackish water. And in my opinion, the Middle East should be reducing their focus on the expensive, energy-hungry desalination plants, seawater desalination plants, and then focus more on brackish water, desalination, which is the least expensive option for them. Because the seawater desalination, when you desalinate the seawater, you can only recover 50% of the water. But when you recycle, when you desalinate brackish water, you can recover 90% of the water. So that is a cheaper option, and it is a better option. And in terms of eco-friendly technology, using a nature-based solution for desalination of brackish water is the best option available today for countries in the Middle East. Now, the desalination, the seawater desalination, has almost destroyed the coastal ecosystems in the Middle East region, because they continue to dump the brine, which is a concentrated salt, which they recover from the seawater desalination process, and that is destroying your coral reefs and the habitat of the fish and other living creature in the sea. So now the next differentiator is we have, this solution, nature-based solution, has a built-in business model and a revenue model that makes it very attractive. So there is a compelling business case here to adopt this technology. So we think this will be a driver, a main driver for encouraging industries, utilities, cities, and municipalities to invest in wastewater recycling technologies. So how do we do this one? So what we do is, for example, I said our sweet spot is municipal wastewater or agricultural wastewater or food processing wastewater. These are all our sweet spots because they contain all the nutrients, the energy, and water. So we extract all the nutrients. So we use the lemnaceae as the main core engine of the circular economy, and we extract all the nutrients and we monetize the nutrients, which creates a value. Then because there is a solid fraction and the liquid fraction in the wastewater, in the municipal wastewater. So the liquid fraction is taken into lagoons, and then we start extracting the nutrients, and then the solid fraction is taken to anaerobic digesters, where we extract all the energy. So we extract the biomethane using a phased sequenced anaerobic digestion technology, which is very efficient in extracting the methane. So the methane is monetized by generating electricity, or by using them as as a fuel, for automobiles. Then, we extract all the water, and the water we extract is potable quality water, that is up to quaternary standards or WHO standards. So it is a drinking water quality water. So the water has a value. So these are all, the major revenue streams we generate in the recycling process. In addition to that, we also integrate other clean technologies like solar, in the water solar, or solar canopies, micro wind turbines, and also where there is a business case, we also integrate hydrogen fuel cells. So we integrate different clean technologies to make it more attractive from the business case point of view. So more value addition and more profitability, and that is the compelling business case we try to create in using this solution. Now, there is a lot of value added applications here. So there are, you may think that it looks like a simple system, but it is not a simple system. It's a very complicated solution, but it is doable. It is a nature-based. So okay, now what are the problems we are addressing in our solution? Now, if you look at this solution we are proposing follows the circular economy principles. So I can even say confidently that this solution is a typical example of circularity in water, which is very important. Now, we address a number of problems which we are facing. Wastewater recycling for reuse, nutrient, energy, and water losses, we are addressing them. And we try to create long-term water security, food security and nutrition, prevention of water and soil pollution, climate change mitigation solutions. If you look at the solution we are providing, it is not a simple wastewater recycling solution. It is a wider climate change mitigation solution, because the plant, the Lemnaceae, which we are using, the vascular plant, is one of the fastest growing plants in the world. So in the process, it is sequestering enormous CO2. Now, we are producing high quality superfood. We are producing renewable energy, and this solution recovers all the water for reuse. So it is basically a climate change mitigation solution and not a wastewater recycling solution at all. We also, desalinate the brackish water, as I will explain. Now, this is the plant. We think this is the plant for the future, because it can address a number of the challenges we are facing now. It is the botanical name is Lemnaceae, and the common name is a duckweed. And so the duckweed is, it is a common plant, and it is seen as a weed. In summer you can see it in Regent Park or in Hyde Park, in the ponds there, in the water bodies there. You can see this, flourishing. So this is available internationally. But this is one plant that has not been exploited by us. They are small aquatic plants, floating aquatic plants, small in size, but they grow very rapidly. They grow in size, twice in size within 24 hours to 72 hours under ideal conditions. So the biomass doubles in 2 days' time. And this plant contains the leaves. They contain up to 50% protein by weight. There is no other plant source which can match Lemnaceae in terms of its protein content. And they hold massive potential, for human consumption, for animal feed, as well as, the plant alternative to, whey proteins. So it can also be, research is also going on for using it for producing, biofuel. So this is a small plant, but with a promising future. So this is exactly, you can see this single plant here. So it's a floating vascular plant, fast growing. And so there are different species, of Lemnaceae, which are used for this purpose. Now, okay, coming back to the solution. Now, this is the simple wastewater system, the simplified wastewater system. So we get the wastewater. This is where the inflow comes. So we use the screen to remove the liquid portion and the solid fraction. And then, we take them to a series of lagoons. So in the lagoons, we introduce Lemnaceae. So the Lemnaceae then, does the treatment process. Now the Lemnaceae does this treatment process, in different phases. In the case of, municipal wastewater, what happens is the municipal wastewater contains more nutrients and less of toxic chemicals or heavy metals, unlike industrial water or mining wastewater, which contains almost no energy and also, less nutrients, but more of toxic chemicals and heavy metals. So that is why I mentioned in the beginning itself that our sweet spot is municipal wastewater, food processing waste, agriculture wastewater, which all contains these nutrients as well as the energy. Now, once the process is over, we use a series of lagoons. First, we strip the nutrients, and the nutrients, for example, the Lemnaceae picks up all the nutrients and it grows. Now, the Lemnaceae, there is no market for Lemnaceae today. So what we do is, we use it for feeding the fish and poultry, and then we produce fish and poultry. So then, we can sell the fish and poultry to generate income. Of course, then, the anaerobic digestion generates another income. And then, the water generates another income. Now, in the first phase, in the lagoons, we strip the nutrients, and in the next lagoon, we strip the toxic chemicals, if any, in the system. And then in the third one, we strip all the heavy metals. And in the fourth one, you get the clear water where we do the polishing. And we do the polishing using UV rays, UV ultrafiltration. So then the resulting water from this ultrafiltration is potable quality, and it can be used for drinking water purposes or for industries as a processed water or for any other purposes in business, for commercial uses in businesses and other industries. So this is another description of the system, the diagram which is explaining the inflow, outflow, and the final products. And if you look at what we are doing with the industrial wastewater, that includes the mining wastewater, etc., the brackish water and municipal wastewater, and the intermediate streams are all the purified water, the nutrients, and the biogas. But the final products, you see, what we are doing is, we are producing engineered lumber or bioplastics or premium bottled water, fish and prawns. So if you look at the fish and prawns, the Lemnaceae protein, salad greens, and vegetables. So these are all the final products. And you may be wondering, how this engineered lumber and the bioplastics are coming here. So actually, what happens is, wherever the Lemnaceae uses, it extract all the nutrients, it is edible. And wherever they are absorbing all the toxic chemicals and the heavy metals, they are not, edible. So we convert them into bioplastics or engineered lumber. And so this is how we take it for alternative uses. So this is another, diagram which explains this system. I will quickly run through this because I'm mindful of the time. So now, what is the business model here? This is a business model. See, look, a 1 hectare Skillicorn system treats 110,000 cubic meters of municipal wastewater in 1 year. And the capex is around $300,000 US. And the project IRR is 15 to 35%, depending upon the composition of the wastewater. And the outputs are, the methane, the water, the lemnaceae, and the lemnaceae is monetized into prawns and fish. And so this is the value of the methane gas we are generating in terms of electricity value, and the potable water we are, producing, and also this fruits and vegetables, fish fillets, which we are generating. So this is the economics. This is the compelling business case that can be built on a nature-based solution like what we are discussing. So this is a layout of a commercial, scale project. So you can see these greenhouses for growing lemnaceae, the lagoons here, and also, the factories for processing, growing fish, everything. So now, what makes our technology so different? So it's 100% biological, natural, and we follow the circular economy principles, lowest cost of water treatment, and low capex, net positive energy production, multiple revenue streams. So I can go on and on, on the benefits, but I'm mindful of the time we have. So I'm just skipping these slides. And specifically, what we can, offer for the livestock industry, which is blamed as one of the major polluters of our rivers and other water bodies. So this is a serious problem, but you cannot blame the farmers because the farmers are, struggling for their survival because the margins are thin. So we can't expect them to invest in wastewater treatment plants. But the solutions which we have will help them because there is a business case, and they can not only address the waste, slurry issues they are facing, but at the same time they can also generate some extra cash, for their survival. So these are all the various benefits we can create for the livestock industry. And again, this is a comparison of our technology and the competitors' technology in the marketplace. And so the slides will be made available to you later on. So I'm just quickly running through this. So yeah, it ticks all the boxes. But you may be, wondering, it is all too good to be true. Yes, there are some limitations which we will discuss it in the Q&A. So we have done this, internationally in different, geographies, in different climatic conditions, and so we know, how this solution works. So the water offset or the water stewardship, this is an evolving concept, and so the clean water projects like what we are proposing using our nature-based solutions are the best carbon offset programs for industries and corporates. So again, I would like to close this by saying that, every $1 you are investing in water and sanitation globally, will deliver a 400% returns in reduced healthcare costs around the world. I don't think I need to, explain this or emphasize, this point. This is the WHO's, statement. So this is the reason why we should, pay more attention to the recycling of wastewater using sustainable technologies or nature-based solutions which are eco-friendly.
Okay, thank you very much for that, Manny. I've got a couple of questions myself. One, the first one you partly answered. I was going to ask, whereabouts have you got installations, and you showed the sort of world picture. Are there any installations or projects that you've got going on in the UK or Europe?
No. See, what we did was, we have done pilot projects all over the world. Originally, when we started, 30 years ago, we used this NGO model because, there were World Bank, ADB, and other donors were, financing our projects. And we did it, in different places, especially in Peru, in Bangladesh, India, and other places, which were financed by different donors. So what we did was we engaged the local partners. We set up the system, trained the people, and we handed over to them. So we realized very lately that this technology has potential. So we set up the company only in 2018. But it has taken a long time for us to create that visibility and also acceptability of our technology. So we are now in the process of setting up our first commercial scale projects in Ireland, in the UK, as well as in Middle East. So we expect that we will start the construction by before this summer in Middle East as well as in Ireland.
Okay, and then the other question was with regard to the lemnaceae. Is that you say it's high in protein then, and you mentioned using it for fish. What is that protein used for anything else then? Well, you mentioned human consumption.
Yeah.
Or is it used for animal feed or anything like that? Or?
Yeah, exactly. Because see, this plant is consumed by the local population in Southeast Asia. It is already used as a superfood. And now there are companies in the US, company called the Parable in US, Pontus in Canada, and Hinoman in Israel. So they're all working on this lemnaceae for as a source of plant protein, alternative protein. So that involves hundreds of millions of investments. So these companies are already started working on this. At the same time, what we are doing is, see, there is no ready market for this lemnaceae. So what we are doing is, we can feed it for dairy cows or beef cattle. We can feed it for fish, prawns, or poultry. So that is a cheaper way to monetize the lemnaceae, because I can't sell lemnaceae as it is. And also, almost 92% of lemnaceae is water. So there are some logistic issues in transporting, in storage, in selling it. So the best way to do it to monetize the lemnaceae is to dry them and convert them into powder and then use them for other applications.
Yeah. Okay. Yeah, because the stuff grows in abundance in the UK, doesn't it? There's ponds everywhere covered in that stuff.
Yes. In fact, I skipped that slide. If you compare to soybean, the lemnaceae uses only 10% of the water used by soybean, but it creates more than 10 times protein than soybean.
Yeah. Because I don't know. Is a lot of the criticism at livestock production is the amount of land taken up to grow the produce to feed the animals. And so I don't know how it compares really in terms of how much acreages of you'd need to grow sufficient lemnaceae to feed animals compared to the land, the same area in land, to produce the same sort of feed levels if it's high in protein.
Yeah, because it's just a concentrated feed, because of its high protein content. It also contains essential amino acids and vitamins. See, what we will advise is for a farmer who is generating a lot of waste, for example, a dairy farm, a beef farm or a poultry farm generates a lot of slurry, the poultry waste, everything, which contains all the nutrients. The best thing is to follow this circular economy principles, set up this treatment plant on site in the in the farm, and then monetize, extract all the energy, so that you can use it as a feed for your animals, for your poultry, and reduce your feed cost. See, increasing feed cost is a huge problem. The margins are very thin for poultry farmers or dairy farmers, mainly because the feed cost is very high and the prices they are getting is low. So it has to be addressed like that. But the companies like Parable or Pontus and Hinoman, they are going in for large scale cultivation of these plants because their objective is to use it for alternative protein.
Yeah, did you mention Bannerman then?
Parable.
Yeah, the people who are doing the methane, fugitive methane. Yeah, they did a presentation at our conference last year in connection with the CNH tractor methane project. So where they're doing the capturing the methane, which I thought was really interesting. Yeah.
And also, we are now talking more about this green hydrogen. So the wastewater recycling projects are the ideal, fit for producing green hydrogen.
Yeah. Okay. So do we have any other questions? There's nothing in the chat at the moment. Anybody else wants to ask a question?
Well, to Manny, to say, can different waste streams be combined from? Does it solely have to be, poultry waste or slurry or pig slurry? Can there be combinations if farmers have different waste streams?
Okay, what you are asking is whether we can combine these different waste streams generated in the farm. Yes, because absolutely, because these are all, animal waste, which contains a lot of nutrients, a lot of energy. See, the biggest problem faced by these, agriculture farms, in Europe or North America is the leaching of nitrogen from their farms. That's mainly because they are using all the slurry, for application to the land. So this is where the runoff happens, and then it pollutes your rivers. So once you extract, by using it in the, nature-based solution systems, so we extract all the energy. So there is no scope for, loss of any nutrients at all. So this will address two things. One is, it will generate some extra income for the farmers because you can generate electricity on site. And so then, you can also supplement your, feed by, using the Lemnaceae as a part of the cattle feed.
I might just add in another one as well, and maybe a question that might come up is that the value of fertilizer from slurries. The farmers might be questioning if they're using it in this system. Are they losing out then? Do they have to buy chemical fertilizer to supplement? So what happens? Is there any fertilizer that can be spread on the land as a result of all this system?
Yes, Mike, this is going to, help them by, as a source of organic manure. The digestate which is coming out of the anaerobic digesters can be used for application to the, for land spreading, and it becomes a valuable organic manure. But at the same time, there is no leaching of the excess nutrients because we would have already stripped these nutrients, in the lagoons. Yes, I think Simon is asking a question about, any opportunity for a pilot project in the UK. Yes, we are working on setting up of, pilot projects in the UK. So we are discussing with a number of potential, partners for setting up this one. And also, we are also talking to some universities also to collaborate with us for setting up of a demo project where we can showcase the entire, suite of our technologies we have developed.
Okay, so, well, thank you very much for that. It's a very, very different presentation, very interesting. Certainly gives people a lot to think about. Thank you very much for giving up your time to do that today. It's very much appreciated. I'm sure people found it very interesting. So I would like to thank everybody for joining us today, and I hope you will join us for our next lecture on the 17th of May where we were joined by Robert Cartmel from Marks and Clark. So Robert will be doing a follow-up presentation to the 2 intellectual property workshops that he did, or his team did previously for us. I'd also like to take the opportunity to remind everybody that we have our annual AGM and awards ceremony on the 27th of April at Class in Saxon. This will include lunch and also a tour of their brand new facility over there. So please do book, as places are filling up very fast. So all that's left to say is thanks again for everybody for joining, and see you again next time. Thank you. Bye-bye.